Hello my dears, welcome back to my channel. Today I'm back with another video. First of all, thank you so much for the love and support. This is the part 3 video of rational numbers. In this video I'm giving you a glimpse of each property of rational numbers. So let's get started. Properties of rational number. We have 4 properties here. First property, closure property, then commutative property, third one associative property, and fourth one distributive property. Apart from this, we have 2 more properties that are identity and inverse property that we can discuss later. See the first 3 properties: closure, commutative and associative. We apply addition, subtraction, multiplication and division on them. On the last one, we do multiplication over addition and subtraction. Now let's see the first property, closure property. If a set of numbers is such that a given operation on the numbers results in a number from that set, then the set is closed under that operation. Consider any set of numbers like natural number, whole number, integers or rational numbers. If we do any operations means any arithmetical operation like addition, subtraction, multiplication or division. If we do any arithmetical operation on these set of numbers results a number, that number should belongs to the same set. Then we can say this property is satisfied under these operations. Okay, I think this is clear now. For example, let's say A and B. A and B belongs to the set of natural numbers. I take the first operation addition here. When I add A plus B, I get a result C. And this C should belongs to the set of natural numbers. Then we can say natural numbers are closed under addition. I think this is clear, and then we can do all the remaining operations. Let's see the next property, commutative property. The word commute means to travel back and forth. Back and forth means going in one direction and then in the opposite direction. If a number is commutative, that means it is movable. The commutative property states that changing the order of addends or factors does not change the sum or the product. Let's see how this is applicable in numbers. Take an example, 3 plus 5. 3 plus 5 is equal to 8. Then we are adding in the reverse order. 5 plus 3 is equal to, we get 8. That means 3 plus 5 is equal to 5 plus 3. We can write A plus B is equal to B plus A. This means changing the order of addends. Changing the order of addends means numbers. Okay, changing the order of addends does not make any difference, right? Both are 5 plus 3 or 3 plus 5, both are equal to 8 only, right? So changing the order of addends or factors does not change the sum or the product. Both are same only. So this is the commutative property. Let's see the next property, associative property. Associative means grouping. To associate numbers means to group the numbers. The associative property states that changing the grouping of addends or factors does not change the sum or the product. This might be look like commutative property. In commutative property was about changing the order, right? But in associative property, it's all about changing the grouping. Okay, let's see the expression 5 plus 7 plus 6. When you find the sum of 5, 7, 6, you of course take any two numbers first. Then you add with the third number. Like that, we can add these numbers in two ways. First, we can add 5 and 7 together, then add with 6. Or else we can add 7 and 6 together, then add with 5. In both ways, answer remains same. See, 5 plus 7 plus 6 equal to 5 plus 7 plus 6 equal to 13, right? So 5 plus 13, that is equal to 18, and 5 plus 7 together, then add with the 6, that is equal to 12 plus 6 equal to 18. In both cases, answer remains same. So this property is called associative property. Addition, subtraction, multiplication and division also applicable on associative property. Let's see the next property, distributive property. The word distributive means we know distribution, right? Dealing or giving a proper share to each one. Here, the distributive property states that multiplying the sum of two or more addends by a number is the same as multiplying each addend individually by the number and then adding the products together. Here we have an example. 5 into 2 plus 3. Here we can multiply each addend individually by the number. See, 5 into 2, then plus 5 into 3. Similarly, 5 into 2 minus 3 is equal to 5 into 2 minus 5 into 3. So we can say A into B plus C is equal to AB plus AC. Like that, A into B minus C is equal to AB minus AC. Here in distributive property, two types are there. That is multiplication over addition and multiplication over subtraction. So this is distributive property.